Okay, so just to reiterate, whenever we see absolute values, all we do is we split it into a piecewise. Then we check from the left side, we check from the right side, and that's basically it. The only difference in our piecewise when we're splitting it up is we just have to turn it into a positive version for numbers where the inside is positive and a negative version where the insides are negative. So for example, if I ask you to do something like this, limit as x approaches 3 of, let's see, x minus 3 absolute value plus 4 or something like that, what you would do is you would split it up into x minus 3 plus 4, where x is greater than 3, and x minus 3, I'll put parentheses for clarity, negative plus 4, where x is less than 3. So basically that's kind of how you would split it. Okay, good. This is something that comes up really often on multiple choice. It's really not very difficult, but it's easy to forget. So as we're doing practice, this is just something to kind of throw in your, hey, don't forget this mechanic. It's really easy, but if you understand the concept behind you're saying, okay, I'm coming from the left, from the right, what is an absolute value doing? And if you understand that, and especially if you graphically understand it, it's pretty easy. You just can say, okay, I just got to check it from here and here. All right, moving on. So the next thing we're going to talk about is limits to infinity. Now, there are a couple of major ideas here. Number one is what happens when the limit as x approaches infinity. And secondly, what happens is when you take the limit and you get a number that is quote unquote infinity. So what we're going to talk about today is mainly we're going to think a little bit in terms of end behavior. In Algebra 2 honors and even pre-calc probably you saw it when you were doing like conics and stuff, or not conics maybe, but like polynomial graphing and stuff. You guys should have seen end behavior, which basically says, hey, is you're going to go negative, positive? Do you have horizontal asymptotes? All of this kind of fun stuff. That was your whole end behavior where you're sketching these graphs and you're saying, okay, where are my zeros? Where are my points of inflection? What's my end behavior? Like those were the things that you're looking at. Basically, when you're saying your limit as x approaches infinity, you're just doing the mathematical version of end behavior. So let's kind of talk about the three basic rules. You should have been familiar with this already, but we're just going to put it in terms of limits in a very mathematical version. So there's three basic rules. If the limit as x approaches infinity for f of x over g of x, where f of x has a higher power than g of x, the limit goes to infinity. So if you have something like this, limit as x approaches infinity of x cubed plus 5x squared over x squared minus 7, this limit is going to be infinity, or the limit's going to be infinity. So when you take it, evaluate it, it's just going to say infinity. And again, the reason why this works is when you're saying the limit as x approaches infinity, you're saying what happens as x gets really, really, really large. So something like 9 with 5 million zeros behind it. That's a really large number. And if you're cubing that, that grows so much faster than if you're squaring that. So like 9 with 5 million zeros behind it, cubed, is so much larger than 9 with 5 million zeros behind it squared, that this number really doesn't even matter at all. So you don't even need to worry about it really. So the main thing you're focusing on is this x cubed. So whenever you're doing limits with infinity, the main thing you focus on is your highest power. And if your highest power on top is bigger than your highest power on bottom, what you're saying is this top number is going to grow so much quicker than your bottom number that eventually, no matter how big your bottom number is, your top number is just so huge, it's just going to keep going up and up and up and up and up because it grows exponentially larger. So what's going to happen is if you take this limit as x approaches infinity, you're just going to say, hey, where's the bigger power? The bigger power is on top. Then that means it's going to be approach infinity. Sort of kind of makes sense. How are we doing? Okay. Now with that in mind, I'm going to go through the next two rules a little bit quicker because we kind of explained the basis behind how this is working. So the next one says, all right, the next rule is given limit as x approaches infinity of f of x over g of x, where f of x has the lower power than g of x, the limit goes to 0. So basically, if your denominator has a larger power, then it's going to be like a number divided by a really big number. So like 10,000 divided by like 9 quadrillion, it's going to be a really small number. 2 divided by 9 with 5 million zeros behind it is again going to be a really tiny number, basically 0. At that point, because the decimal is going to be so small, we say, it's effectively 0. It's like rounding. Finally, the third one is given limit as x approaches infinity of f of x over g of x, where f of x and g of x have the same power. The limit approaches a over b, where a and b are the lead coefficients of f of x and g of x respectively. So basically, this is saying if you have the same power, all you do is you take coefficient over coefficient. So if you have something like this, 3x cubed plus 9x squared minus 17x all over 5x cubed minus 1, limit as x approaches infinity. Whoops. Then what's going to happen here is your final answer is going to be 3 over 5. Again, you don't need to worry about anything else other than your highest power, because everything else is so infinitesimally small when you take stupidly large numbers that it's not even worth thinking about, so you just kind of ignore it. Like, basically, that's what's happening. It's kind of like Asian families. If you have the firstborn, nothing else really matters. Questions? Okay. One thing that you do have to watch out for, though, is you do have to watch out for negatives, and I'll talk about that in just a second. So here's the Mori version, basically. So the 3 basic rules burn down to this. If your top grows faster, it goes to infinity. If your bottom grows faster, it goes to 0. And if they grow at the same rate, then it's based on the coefficients. How do you tell what's growing quicker? Look at the powers. Whatever has a higher power grows faster. Now, this also works for things where x is in your exponent as well. So I'll show you a couple of special cases real quick, but I'll just show you one really quickly. But if I have something like this, 2 to the x over 2 to the x plus 1, the higher power is obviously going to be this bottom one. Even though it's only one bigger, it doesn't matter. That's the one that grows larger. And when you take stupidly large numbers, this is the one that's going to grow quicker. But you can actually reduce it, so you got to watch out. So it's going to be 2 to the x over 2 to the x plus 1. And then really, this is just saying 1 over 2. So again, that's where you have to reduce things, and that's where it gets a little bit complicated. Now again, I kind of did some hand wavy things here. I'm assuming you guys know your exponent rules fairly well, and you're fairly competent when it comes to working with general terms and exponentials with variables in them. Does everyone understand why this limit's going to be 1 over 2, assuming that its limit as x approaches infinity? Okay, I'll explain it really quickly. So basically, if you have x's in your exponents over here, you just got to simplify. So then we have limits as x approaches infinity of 2x over 2x times by 2. Now the reason why I'm doing this is basically what I'm doing is I'm splitting up your 2x plus 1. And 2x plus 1 is just saying 2 to the x times by 2 to the 1. Because your exponent rules say if you multiply two things with the same base, you add their exponents. So that's basically what I'm doing, is I'm splitting up this into this, and then I'm using it to write it like this. Then from here, we just cancel out the 2x's, limit as x approaches infinity, 1 over 2. And since there's no x's here, it just becomes 1 over 2. Kind of makes sense. Okay, so again, that exponent rules and stuff, they're not, I'm not gonna say they're general guidelines, but you do kind of have to look at them in context. Okay, any questions on the rules? We're gonna go over like examples and special cases in just a minute, but do we kind of get the general gist? All right. Good, good, good. All right. So when we have this over here, let's just kind of take it really quickly. What is your limit as x approaches infinity of x over x plus 5? Take 10 seconds, type it out really quickly. The answer should be really quick. Type it out, but do not submit it until I finish counting down from 10. 10. 5, 4, 3, 2, 1. What do you guys got? Okay, almost everyone got it correct. I only saw one incorrect answer where someone put a question mark after it, but there should be no question mark because we don't second guess ourselves. We are confident, we are competent mathematicians, and the answer isn't 1, it's 1. Okay, so please be confident with your answers. But yeah, super simple. It's just our third rule, the coefficient. We just look at the coefficients. Okay, let's try this one out really quickly. Same thing. I'm going to count down from 10. Please do not submit until after. If you have a question, feel free to type it out and I'll watch it. But again, I'll count down from 10. Try this out. 10. 5, 4, 3, 2, 1. What do you guys got? Yeah. Good, good, good. Looks good. Okay, really quickly. Now, I talked about this in terms of end behavior. Did you guys kind of learn this when you went over end behavior already? I'm just kind of curious. You've never heard of end behavior. Interesting. Okay, I have to have a talk with Miss Konishi instead of that. Ah. For this one over here, Kaiki, 2x limit as x approaches infinity, 2x over 2x plus 1. Yeah, so in this case, the denominator is larger. However, there is something that's a little bit weird. This isn't a polynomial. Sorry, I should have wrote that in the rules. It was f of x and g of x where they're polynomials. Technically, this is not a polynomial. This is an exponential. So it doesn't necessarily follow the exact same rules. So then this one here, we just kind of simplify. Now, the main reason why that rule works, again, is you have something like 2 x squared, or excuse me, x to the squared over x to the 1. The reason why it works, again, is, sorry, let me move this here. The reason why it becomes infinity here is because this x gets larger and larger. As your base gets larger and larger, squaring it becomes so much more powerful, right? Like, I'm not saying large like 10 million. I'm saying large like 10 with 10 million zeros behind it. That's a slightly larger number. And so when you're squaring that, it becomes so much larger than just not being squared that it goes to infinity. However, if I'm just doing something like this, 2 to the x over 2 to the x plus 1, even if I have a number like 10 with 10 million zeros behind it, really, I'm dividing it by 10 with 10 million zeros, but only one larger. This here is always going to only be 1, 2 greater than this top one, because I'm not squaring a big number. I'm taking a small number and I'm multiplying it, and it's not growing exponentially larger than the bottom one anymore. The difference between these two is only by a factor of 2. This one's always just going to be 2 times larger. You can always simplify it. But yeah. Okay. But yeah. These three rules are for polynomials. I should uh, reiterate that. These three rules are for polynomials. So watch out for exponentials and stuff. It's easy to just kind of assume, which is why I wanted to highlight it. Interesting. You guys never did end behavior. That's not the end of the world, but like when you guys were graphing polynomials, right? That's where you had to say something like, okay, is there like a horizontal asymptote or something like that? Like, oh, it like flattens off here or it flattens off here. Or like, oh, it just gets really, really large. So like your end behavior looks something like, oh, it's up here and down here and there's like this middle part here and you just connect the dots. You've never done anything like that with polynomials. Well, I guess you might just do it in calculators. I gotta talk to Miss Konishi about that. It's just interesting. Anyway, not the end of the world. All right. Listen over here, same thing. Try it out. What do we got? What is my limit going to be? Count you down from 10. Again, don't submit it till we hit 0. Okay. 5, 4, 3, 2, 1, 0. Yeah, your denominator is larger, so it's 0. Good, 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 good. Very good. Okay, you guys didn't learn it as end behavior. That's fine if you guys learned it incorrectly. Okay, so yeah, it's gonna be 0. Your denominator is larger. So now let's look at one that's basically the exact same thing, but I want to highlight something. Now, one thing you have to watch out about is positives and negatives. Now, obviously, I didn't want to show it to you when we first went over it just to make it super simple, but you always want to check it, not just when you're going to negative infinity, but even when you're not going to negative infinity. You always watch your symbols. Now, basically, what you're going to be doing here is this is going to be going towards 0. And that doesn't really matter. But the reason why you kind of gotta watch out for this just a little bit is because here's what's happening. This top number, you're having a negative number cubed. So when you have a negative number cubed, what is that going to be? It's going to be a negative number divided by, if you have a negative number squared, you're going to be getting a positive number, or to an even power, I should say. So you're going to have a negative divided by a positive. So basically what's going to be happening is as you're approaching negative infinity, you're approaching negative infinity as a negative number. So sometimes they'll ask you to do things like identify which of these graphs could be this function over here. And you're given two options, one that looks something sort of kind of like this, and one that, excuse me, let me just draw it a little nicer, one that looks something sort of kind of like this, and one that looks something sort of kind of like this. This one over here would be your answer. The reason why this one would be your answer is because you know as you're approaching negative infinity, you should be dealing with negative numbers. Even though they both approach negative infinity, you do have to kind of watch out for that. And I'll show you why this actually makes a really huge difference in a couple problems in the future. But for now, that's just something you have to watch out for. Okay, any questions on this? Do we get the general gist? Okay, so basically, whenever you're doing this, I'm going to add another layer of complexity. Watch out for your negatives. You have to watch out for positives and negatives because sometimes it affects your answer. In this case here, one thing you might want to watch out for, like a common problem that they show you, is they'll give you two graphs, one that looks like the one on the left and one that looks like the one on the right. And then they'll ask you which one of these two could be representative of the function 12x cubed plus 16x squared plus 73 all over 5x to the fourth. And the answer is going to be the bottom one. Excuse me, the right one. The reason why it's going to be the right one is because you know that when you're taking these numbers, you're going to be getting a negative number divided by a positive number, which is going to be a negative number, which is like when you guys were doing sign charts. So that's just something to watch out for. There are a few different contexts where you would use that, and I'll show you what they are, but for now, just something to keep in the back of your mind. Okay, any other questions? Doing all right. All right. Let's see. Okay, whoops. So here, sorry, I forgot to change this problem. But let's look at this really quickly. Limit as x approaches negative infinity of 7x cubed over 3x squared plus 5x minus 2. So if I give you something like this and I ask you what is the limit going to be, evaluate the limit. Your answer, according to my rule, was it should be infinity. The reason why it's going to be infinity is your top power is larger than your bottom power. But what you know is that when you take this number here, you're getting a negative number cubed. And when you take a negative number cubed, that's going to be a negative number divided by a negative number squared. And when you take a negative number squared, that's going to be a positive number. So you're not necessarily going to infinity. You're going to infinity, but to negative infinity. That's where you kind of got to watch out. Now, excuse me. Obviously, you can't just say, oh, if it's negative infinity, or if it's approaching negative infinity, it's going to be negative infinity. Positive infinity, it's going to be positive infinity. You always want to do this quick sign check, and I'll show you why. Sometimes you get stuff like this. X approaches negative infinity, limit as x approaches negative infinity of 3x to the fourth over 7x squared. And in this case, even though you're approaching negative infinity, your answer is actually going to be infinity because your top power is greater. But when you take a negative number squared, you're going to get a negative number or a positive number. When you take a negative number to the fourth, you're also going to get a positive number. So it's going to be positive over positive, which is going to be infinity. So it's kind of like when you're doing like sign charts and whatnot. It's the same general concept. Does this sort of kind of make sense? We're doing all right. Okay, so just to clarify it one last time, basically what's happening is there are two things that you're doing when you're looking at these infinities. Number one, you do your hello brain, you do your three rules check. You're checking to see, hey, is it going to go infinity, 0, or is it going to go to some number? Then after that, you do a quick check. Okay, is this top number positive or negative? Is this bottom number positive or negative, using your exponents? So it's kind of like a 2-for-1 kind of thing. Okay. Why do I have the same question 3 times in a row? All right, let's try this out. Okay, if I'm giving you this really quickly, what is your limit going to be? Again, don't hit enter. I'm going to count you down from 10, and then you'll hit enter. So again, 10 seconds. 10. Okay, 5, 3, 2, 1. What do we got? Yeah, negative half or 1 over negative 2. Doesn't really matter. Basically, what's going to be happening is it's your third rule. Your top and bottom power are the same, so you're going to be left with 1 over negative 2. And then when you take x to the third as a negative, it's going to be a negative number as a negative number. And then we have a negative number on top divided by a negative times a negative is a positive number, so you're left with a negative number. Again, it's basically 2 steps. Number 1, evaluate whether it's 0, infinity, or just some number. And then after that, you're going to be just checking your positives and negatives to double check. Easy enough. Questions? Okay, on a scale of 0 to 10, how comfortable do we feel with this? Just initially, 0 being really not sure, 5 being get it decently well, probably gonna make a handful of mistakes, 10 being like, oh yeah, got it, super easy, feels good. Where are we at? All right, we're in the 7, 8 range. I can live with that. We'll see on the homework. That's fair. All right, let's go. So just as a super quick recap. Now, the main reason why I'm putting this in was just so that way you guys have something to see as a quick note. So if you guys are looking at the PowerPoint, it'll be all there. But this is, again, what it is. Again, this is for your polynomials, your 3 basic rules. If you're given f of x where x is higher, it goes to infinity. F of x over g of x where g of x is higher, then it goes to 0. Then you look at your lead coefficients if they're the same. And then always check your negatives and positives. All right. Now, there are some less straightforward examples. So here's what I want you guys to do. As always, I want you guys to jump in your groups. So feel free to jump in your groups there. I will be screenshotting this and posting this up. So jump in your groups really quickly and then come back here in 5 minutes. So at 1:45, I'm going to grab water real quick. Again, feel free to pop back in if you have questions, but I'll screenshot this, post it in the chat, and then let me know if you guys have questions. Try this out. All right. 5 minutes. Good luck. Okay, please have each of your groups have one person type out whatever you guys got for the answer, and then be ready to explain. I'll just pick someone random from the 4 people that type it out. If you don't have an answer, just say weren't able to figure it out. Okay, what do we got? Okay, we got 2 answers, waiting on 2 more. Ooh, interesting. We're split down the middle. All right. So we'll have Jasmine go first. Jasmine, can you please explain us how you got 0? Hmm. That's fine. I'm the best person to explain this, but we'll go with second best for now. That's kidding. All right, what do you got? You can do it. Mm-hmm. What were your exponents though? Because we have this square root thing now. Yeah. Because you have this square root thing and you obviously can't just distribute the square root, right? Okay, so the reason why this is a little bit different is it's not a standard f of x over g of x anymore, right? What it is really is it's an h of f of x over g of x. So how are you dealing with the fact that it's all being square rooted? Or is it just kind of like the irritating person at school where you ignore them and pretend that they're not there? What are you doing? Okay. Jordan or anyone who is in Jasmine or Jordan's group, how did you guys deal with the square root? To square it? Interesting. Interesting. What do you mean by that? You could have rationalized it and got a different answer. Mm-mm-mm. I made square root as 1 over 2. So an exponent of 1 over 2. Yeah, that's fine. You can make square root of 1 over 2. Jenna and Akiko, I'm going to guess that the reason you got do not exist is not because you used conjugate. Did you guys use conjugates? No. No conjugate for Akiko. No conjugate for Jenna. Now, that was a nice idea. I like the idea of using conjugates because we see square roots, but there's something that you can't do. You obviously just can't square this. Now, the reason why you can't just square it, and I want to explain this really quickly, is if you have something like this, x over 3, you can't just say times by 3 and get rid of it because you can't just magically pull a times by 3 out of nowhere, right? If you wanted to do something like this, you would have to say, okay, I times by 3, then divide by 3. It's kind of like when we're doing completing the square type things, when we have things like x squared plus, let's make it easy, 6x plus 7. You want it to be 9. You want this number to be 9, but you can't just randomly add 2. You have to add 2, then subtract 2, so that way you don't change your expression. You can't just square it. If you have square root of 2x, you can't just say, okay, this becomes 2x squared, unless you have an equal sign, 7. And this is equal to 7 squared. The only time you're allowed to square something just randomly, quote unquote randomly, is if you're doing it to both sides of an equation because you're not trying to preserve what the number is. You're trying to preserve the equality of the two sides. So when you see a square root, you can't just get rid of it. again, I get the idea, I understand it, but that's something that's really important that you have to remember. Whenever you're dealing with expressions, you can't square things, you can't just multiply. You can do one thing to the top as long as you do one thing to the bottom. No, that only works for multiplication. Because here's what's happening, it's 9 over 1, okay? And then if I square top and bottom, I'm gonna get 81 over 1. Are these two numbers the same? Or excuse me, is 9 over 1 and 81 over 1 the same, even though I'm squaring top and bottom? No, it's totally a different number now. That's why it's different. Now, if I had something like 9 over 1 equals 3 squared over 1 squared, and I squared both sides here, I would have not 9 squared over 1 squared equals 9 squared over 1 squared. And these are the same. Even though the numbers are different than they originally were, the equality is preserved. That's why you're allowed to do it to both sides of the equation. So that's the tiny thing. I'm going to tell you right now, the way you deal with this square root is you ignore it and just throw it on at the very end. We actually taught you guys that you were allowed to ignore it and throw it on at the very end. Using this. This was last lesson's rule. And the power rule says that if I'm squaring a function, what I can do is I can just take the limit as x approaches c of the function and then square it after, or you do the power after. Same thing with the roots. We said that I can just take the limit as x approaches the number of the function and then deal with the square root later. Okay, so just as a quick note, if ever you see like square roots over something like this, you can just ignore it and deal with it later. But that's because we established that rule last time. So if you're doing this, you guys were correct. Basically, what you're going to be doing here is we say limit as x approaches infinity of 3x cubed minus 12x squared over 5x to the fourth plus 17, and then we just square root this after. You could also write this as raised to the 1/2, but basically you're allowed to rewrite it like this because of that root rule that we talked about last time. Does this sort of kind of make sense? Sorry. Ah, yes, so it is 0. Maybe. Because this is 0, so, and the square root of 0 is 0. So that's how you got that. Now my question then is Akiko or Jenna. So let's have Jenna. Jenna, how did you get 0? Or excuse me, how did you get does not exist? What did you do differently here? Mm-hmm. Very good. Now here's the thing. We're square rooting a negative number, but at the end of the day, isn't it basically going to be 0? Yeah, it's basically going to be 0, but am I ever actually using 0? I'm not. I'm effectively coming really, 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 really close to 0, but I'm not actually using it. And the reason I'm not actually using it is because, again, all of my numbers are below, and it's like a horizontal asymptote. You get super crazy close to 0, but technically you're not using 0. It's technically a really tiny negative number. So the correct answer in this case is D, N, E. So good job to the first two groups. Second groups, you guys were definitely on the right track. But one thing that you have to watch out for, and I highly recommend you at least ask me questions, is if you're like, wait, can I just like ignore the square root and deal with it later? So, because there's a lot of tiny mechanics that you should have learned from Algebra 2 or stuff like that that you want to make sure that you are allowed to do it. So if you're ever not sure if you can do a mechanic, make sure you ask. It's better to ask, get it out of the way, and know, okay, I am allowed to do this, rather than just close your eyes, throw a dart at a board, and just hope it sticks. Do you have to show work for that? If you said DNE on your homework, I'd be totally fine with that. Most likely, if I put it on a test, I would say part A is evaluate the limit. If it does not exist, explain why. Like, I would just throw that on a test, or I would do it like part B, explain your reasoning. Because the numerator was negative, the answer is DNE. So technically it's a negative divided by a positive. So technically all of these really, really close to zero numbers are all going to be negative numbers if you look at your sign chart. So it's a negative divided by positive, so you're square rooting at the end of the day a negative number. So that's why it's DNE. You can't square root a negative number. It's a complex number. But we don't account for that in this case. Okay, how we doing? We're doing all right. Okay, any questions on this? Just give me a quick doing good or something if you guys are good, and then I can move on to the next question. Okay. All right, let's move on to our next one. All right, same thing. I'll give you guys about 5 minutes to work on this. See if you guys can figure it out. Good luck, have fun. I have the question. I will be posting it in the chat. Jump in your groups. Come back at 1:52 or 2:02. So again, basically what you're going to be doing is you're simplifying. So whenever you have these, you kind of simplify. So first thing that we did was the bottom half is the same denominator. So we said 2 times by x to the negative 2. Then we flipped the denominator, that negative 2, up to the numerator to get x squared times by x to the negative 1 plus x to the negative 3. Then we converted those to positive exponents just to make sure that we had it correct. So then from there we had limit as x approaches infinity of x squared times by 1 over x plus 1 over x cubed all over 2. Then we just made them have the least common denominator, which was x cubed. So then we multiplied the left one by x squared over x squared. And then from there we just simplified to get x squared times by x squared plus 1 all over x to the third all over 2. And then we just simplified that to get x squared times by x squared plus 1 all over 2x cubed. And if we distributed that x squared, we would end up getting x to the fourth. So it would be x to the fourth over x squared. Or excuse me, x to the fourth over x cubed, which would have given me infinity, which you guys had correct. Okay. Very good. Yeah, pretty straightforward. Just simplify. Any questions on this? Okay, we doing good? Okay, moving on. Try this out. Okay, again, 5 minutes. So we'll give you to 2:17. At 2:17, that's the hard end time. So make sure you're back in here by 2:17. Same thing. Choose someone to type out and respond. So this is actually going to lead us into our next section. So one thing that we have to look at here is we're saying limit as x approaches infinity of arcsecant x. So basically what this is saying is arcsecant is really weird because it's an inverse trig function. It's 1 over cosine negative 1 x. So we're saying basically where is this going to be 0? Where's that cosine going to be 0 basically? Where is this whole thing going to be equal to 0? And that's why it's pi over 2. Okay, very good. So here, now with our next thing, basically, The next thing we're going to talk about is limits going to infinity. Not limits as x approaches infinity, but limits going to infinity. And one of the most common ways where this happens is, or pretty much the only way, is when I have a variable in my denominator like this, and then my denominator is going to be 0. Now let's look at this really quickly. Basically, my limit as x approaches 0, normally we would say it does not exist, but basically what's happening here is my number is getting smaller and smaller. So it's like 1 over 0.0001, and it gets closer, 1 over 0.00001. And what you know is really this is saying 1 over 1,000. 1 over 100,000, or I'm too lazy to count zeros, 10,000 or whatever. But basically what's going on over here is it's 1 over this, 1 over this, and when I'm dividing by that, really I'm just multiplying by the reciprocal. So the closer I get to 0, the smaller my decimal gets. What really is happening is this number is getting bigger and bigger and bigger, and so really this number is actually going towards infinity. So when you're taking limits, if you have your x in your denominator and it's getting closer and closer to 0, if your denominator is getting closer and closer to 0, what's happening is your whole number is getting closer and closer to infinity. Does this sort of kind of make sense? I'm kind of breezing through it because this is something that you guys should have learned or seen at least before in pre-calc. When you guys talked about like getting closer to 0, and you should have seen this before. So I'm just making sure that we're good. Does this make sense? Now, one thing that you have to watch out for is if you notice I said from the right. The reason why is from the right, obviously it's a positive number divided by a positive number, so it's going to positive infinity. But if I took it from the left, x approaches 0 from the left, it's a positive number divided by a negative number, which goes to negative infinity. So again, just another thing, watch out for your positives and negatives. Okay, moving on. So if I were to say something like this, your limit as x approaches 0 for 1 over x, your answer is does not exist. The reason why it does not exist is because on the right side, you're approaching infinity. On the left side, you're approaching negative infinity. If you look at the graph, like if you were to graph this on a graphing calculator, your graph would look something like this. And if you're looking on the right side, yeah, I go to positive infinity. On the left side, I go to negative infinity. So if they don't approach any specific thing, if they curve away from each other, you can't say that they approach anything. Even if it's something that's a little more abstract like infinity, one's positive, one's negative, they're totally divergent. So because of that, we say the limit does not exist. Okay, so when you have these infinity limits, just watch out your left and right side. Again, really similar to what we talked about earlier. Just always check your positives and negatives. Look at it for context. Make sure you understand what it's saying. Now, if I were to say something like this, if I were to say have something that looks a little bit more like this, then yeah, this would, sorry, this is such a terrible drawing. Let me draw it just a tiny bit nicer. If I were to have this and I were to ask you what's the limit would be infinity. Even though it's like, okay, but there's like, they don't connect, it's not nice, that's fine. They're both going towards infinity as you're getting closer and closer to 0. Makes sense. Doing all right. Okay, so really quickly, last 2 slides over here. Basically what's going to happen is what happens if your function, so then we're going to just kind of check this out really quickly. We're going to take the limit here. Obviously it's going to be 1 over 0. There's no way that I can simplify it, so it's going to be going towards this number. This denominator is getting closer and closer and closer and closer and closer and closer to 0. As it's getting closer and closer and closer to 0, let's see, limit as x approaches -2 from the right, and limit as x approaches -2 from the left. And if these two are the same, then we can say that it approaches positive infinity or negative infinity. And if they're different, we just say the limit does not exist. So when you have these denominators are zero thing, again, you're kind of looking at saying, okay, basically your limit's approaching infinity. So let's check it really quickly. So if I'm approaching it -2 from the right, what that means is I'm choosing stuff like negative 1.999999999, so on and so forth. And then so what I'm going to have is limits, or excuse me, what I'm really going to have is 1 over negative 1.9999 plus 2. This number here is a positive number. So it's 1 over a really, 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 really tiny decimal squared. So then this over here is going to end up being infinity. Does this sort of kind of make sense? You don't need to show this as work. The reason I'm showing this is because this is something that you guys should be thinking and looking at. But then I'm just kind of explaining the mechanics behind how it works. So again, you don't need to show this. You don't need to show this. I'm just showing it so that way maybe instead of just trying to think of it all cerebrally, you guys can kind of quote unquote visualize it a little bit. Doing okay. All right. And then after that, from the left side, it's the same thing. But again, it's like negative 2.000000000001, something like that. And then what we're going to do is we're just going to evaluate it again. 1 over negative 2.000 ... plus 2, and again this is going to be a negative number this time, so it's 1 over negative point ... 1 squared. And again, this is going to be a crazy huge number, but it's still going to be a positive number because of that squared. So because of that, this is going to be going towards infinity. So if I ask you what is this limit going to be, the limit is infinity. Any questions on this? Doing okay? Okay, so just as a super quick review. So we covered absolute value limits. Now when we're covering absolute value limits, pretty simple. All you do is you split it into a piecewise. Make sure that your number approaches the same as the left and the right. And again, if they don't approach the same number, then the limit does not exist. Secondly, when we are doing limits as x approaches infinities, there are 3 rules mainly. Number 1, if top is larger, it goes to infinity. If bottom is larger, it goes to 0. If it's the same, it's coefficients. Watch for your negatives and positives. And again, use your different tools. Simplify. Make sure that you know your different rules. So if you have like square roots, you can move it to the outside. Watch out for stuff like that. And then finally, limits that go to infinity. So basically limits where your denominator is going to be 0. Just do a quick check to make sure your positives and negatives, and it either goes to positive infinity, negative infinity, or does not exist. So just watch out for those. Okay, are there any last minute questions about today's lesson? No? Alright, so with that, the homework is up, the PowerPoint is up. Feel free to use those to help you out. Tomorrow I'm going to be on, I forget what time I said I'd be on. I have it in my announcements in my calendar. Yeah, tomorrow and Thursday I'll be on from 2 to 5 if you need help. Now, if you need help before then, or if you're not able to make those times, feel free just to message me, say, hey, Mr. Morimoto, can you just help me out real quick? And I'll be more than happy to help you out there. But those are the times that I'll kind of block out. So I might be doing something at the time, but I'll try to make sure that if you ask for help, I'll be on. I'll try to get the answer key up for both of these up, hopefully by today, maybe 7 o'clock-ish at the latest. But we'll try to get that up. All right, any last minute questions, comments, concerns? Well, if you do, as always, I'll be on just a little bit longer. If not, I'll see you guys